Astronomers have detected mysterious radio signals pulsing every 2 hours from a dead star system unlike anything seen before. Could this cosmic beacon rewrite what we know about stellar remnants? A decade-long cosmic mystery has finally been solved. Astronomers have traced strange, repeating radio pulses to an unusual binary star system. The signals, detected every 2 hours, originate from a white dwarf and a red dwarf locked in a tight orbit. Their magnetic interactions create intense bursts of energy, similar to those previously associated only with neutron stars. Unraveling a decade-old space enigma for years, scientists were puzzled by periodic radio pulses from a region near the Big Dipper. First detected in 2015, these signals repeated like clockwork, sparking speculation about their origin. The breakthrough came when an international team, including researchers from Northwestern University and the University of Sydney, used multiple telescopes to pinpoint the source. Rather than a single flashing star, the signals were traced to a binary system located 1,600 light-years away. It consists of a white dwarf, the remnant of a dead star, and a red dwarf, a much cooler and dimmer companion. The two stars orbit each other so closely that their magnetic fields interact, producing radio bursts every 125 minutes. White dwarfs can mimic neutron stars until now. These kinds of periodic radio signals were only linked to neutron stars, ultradense stellar remnants known for their magnetars and fast radio bursts, FRBs. This discovery reveals that even lower mass objects, like white dwarfs, can produce similar signals under the right conditions. There are several highly magnetized neutron stars, or magnetars, that are known to exhibit radio pulses with a period of a few seconds, said Charles Kilpatrick, an astrophysicist at Northwestern University. A high-tech treasure hunt. The pulses were first identified in archival data from the Low Frequency Array, LOFAR, one of the world's largest radio telescopes. As scientists combed through past observations, they found additional signals dating back to 2015. These pulses resembled fast radio bursts, but lasted much longer, sometimes several seconds to minutes. To confirm the source, researchers conducted follow-up observations using telescopes in Arizona and Texas. Instead of a single object, they found two stars orbiting a common center of gravity. Their rapid, synchronized motion confirmed that the red dwarf was being tugged around by an invisible but massive companion. Magnetic clashes and cosmic beacons. The key to these mysterious radio pulses lies in the magnetic interactions between the two stars. As the white dwarf and red dwarf orbit each other, their magnetic fields twist and reconnect, unleashing bursts of energy in the form of radio waves. The white dwarf is particularly faint, making it difficult to detect directly. However, by studying how the red dwarf's movement changed over time, scientists calculated the mass of its companion. Their results matched the expected mass of a white dwarf, providing strong evidence that such systems could be responsible for other unexplained radio transients. A new frontier in astronomy, this discovery is just the beginning. Astronomers plan to conduct ultraviolet observations of this system, known as ILTJ 1101, to determine the temperature of the white dwarf and reconstruct its past. By studying similar objects, scientists hope to understand how white dwarf binaries evolve and whether they could be responsible for more of the mysterious long-period radio transients seen across the universe.